Good morning, everyone. Welcome to another session of image processing. Myself, Dr. R. Sudhir Babu, Associate Professor, the Department of Electronics and Communication Engineering, Chief Pullareddy Engineering College, Autonomous. So, the last class we have completed discussion on the fundamental components required to build an image processing system. So, the basic hardware components that we have discussed are starting with the imaging sensors and a computer, the hard disk, and specialized image processing software, and image displays, and finally the hard copier. And if application demands image to be transmitted from one place to another place, so we need to connect the computer to the internet. Okay, so today we'll discuss the mathematical formulation of a digital image. So this is basically a simple image formation model. Today we'll discuss the topic simple image formation model. Right. Sorry. So the couple of classes back, we have discussed the fundamental definition of a digital image. So the digital image is defined. It was defined something like this: image is a two-dimensional light intensity function, generally denoted as f of x y, where x and y are spatial coordinates. And the value of f at any pair of coordinates is basically called as amplitude or intensity. The value of f at any pair of coordinate x naught, y naught is called as amplitude or intensity or gray level. Right? If the spatial coordinates are discrete and the gray level values are also discrete, then image is called as a digital image. So this is how we have defined a digital image. And for our discussion is concerned, the images are monochrome images or black and white images, where the monochrome images are said to be produced by monochromatic light sources. So monochrome images are produced by using monochromatic light sources. So the light is basically a physical phenomenon, and here the intensity or the gray level of a monochromatic image, which is produced by a physical light source, right? Yep. So since the intensity is a physical quantity, so the images produced through the monochromatic intensity of xy, the values should lie between 0 to infinity, because energy is a non-zero finite value, right? So the value of f of xy actually depends on two quantities. First is the amount of illumination falling on the object in the scene, and the amount of illumination reflected back by the object in the scene. So The formation of image basically that depends on two important factors. First is the amount of illumination that is falling on the object in the scene, and the amount of illumination that is reflected back by the object in the scene. So the amount of illumination that is falling on the object is called illumination component. And the amount of illumination that is reflected back by the object in the scene is called reflectance component. So in general, the illumination component is represented as I of xy, whereas the reflectance component is represented as R of xy. So this image is basically, it is a combination of illumination component and reflectance component. So from the fact that the both should exist, illumination and the reflectance should exist in order to create an image, the mathematically the image is represented or modeled as the product of illumination I of xy and R of xy. So this is the standard mathematical representation of a digital image, or this is basically the mathematical model of image. So I of xy is the illumination component and R of xy is the reflectance component. Yes. Now let us see what are the limits for these illumination and reflectance components. See, the I of xy, the illumination, the amount of illumination that is falling on the object in the scene completely depends on the physical source, physical light source. So since it is a physical energy, so I of xy values must be non-zero finite. So I of xy must be between 0 to infinity. So coming to the reflectance R of xy, the reflectance is the amount of illumination that is reflected back from the object in the scene. So which will be captured by the image sensors in order to produce the image. So R of xy completely depends on the physical characteristics of objects in the scene, isn't it? So depending on the physical characteristics of object in the scene, so the magnitude of the reflected light depends. So if the property or the characteristics of object is in such a way that it will absorb the complete energy, then the amount of energy that is reflected back is zero. Or if the characteristic of object in the scene is in such a way that it will reflect complete or the full 100% energy back, then the reflectance value is considered to be 1. So the reflectance values R of xy will basically lie between 0 to 1. So 0%, 100%. So 0 represents complete absorption, whereas so the reflectance value of 1 or 100% represents complete reflection. Right. So since we'll be dealing with only monochromatic images, so the value of the monochromatic image at any pair of coordinate, the value of monochromatic image at any pair of coordinate x0, y0 is called gray level. And the gray levels are said to span in a grayscale. The gray level L value basically lies between L minimum and L maximum. This range L minimum, L max is called grayscale, where L minimum can be denoted as minimum intensity, So this can be mathematically modeled as I minimum into R minimum, whereas the L max can be represented as I max into R max. Okay, right. And here the grayscale, the range between L minimum, L max is, or it will be containing the intensities. The minimum intensity is nothing but black. The maximum intensity is nothing but white intensity. The values between minimum and maximum will be having different shades of grays. Different shades of gray values. So the grayscale will be extending from black to white, and between black to white, so we'll be having different shades of grays. Grays. Yep. So in the context of monochrome images, the grayscale generally represented as R. So it will be represented like this: 0 to L minus 1 instead of L minimum to L maximum. The grayscale in the context of monochrome images in image processing is represented like this: 0 comma L minus 1. 0 is the minimum intensity and L minus 1 is the maximum intensity of the image pixels. So 0 represents black intensity and L minus 1 represents white intensity. The values between 0 to L minus 1 represents different shades of grays. Okay, so let me show you the grayscale of a monochrome image. Yep. See this? So this is the grayscale corresponding to a monochrome or black and white image, so which is the result of monochromatic light source. So here the grayscale extends from black. The grayscale extends from the black to white. The grayscale extends from the black to white. Between black to white, we'll be having different shades of grays. Yes. Yes. So this is about the simple image formation model. So the mathematically, a digital image is represented as, it is a product of illumination and reflectance. F of xy is mathematically modeled as I of xy into R of xy. Yeah. Yep. So we'll stop our discussion here, and so we'll discuss the next concept in the next video. Thank you.